in 1 byte?
Eight types of combinations.
In 1 byte, how many combinations you can store? Maximum. I have full version also. Oh, no.
256.
256. That's good. Why are you saying 256? What's the IP address? Can you just tell me? Can someone 23 dot 23 dot something?
229.8.
0.8.213 213. Okay, let it be there. So in 1 byte, how many combinations of data you have? So Hemant said 256. That is correct, right answer. And Hemant, how do you say 256?
2
Sir,
power
1
8.
byte is equal to 8 bits.
Okay, good. So Hemant is talking in bits. Then 8 bits means
2 power 8.
2 power 8. So he's
2
saying binary 8 bits. 8 bits. Okay, in 1 byte we can store 8 bits and it's 256 combinations including 0. 255 proper number decimal. So we can store from 0 to 255 decimal. 255 decimal number we can store in 1 byte itself, but you have to store in bits. Okay, a number which is 100 you can store in 1 byte. How do you store? If you store 100 as a usage display, each you are going to store 1 in 1 byte, 0 in 1 byte, 0 in another byte, 3 bytes. But we are going to store 100 in 1 byte. How do you store? You convert into a binary and store. So in maximum in 1 byte you can store 256 combinations, because you can store up to 255 decimal number, and we have 0 also. 0 is also one number. So you can have 256 combinations, which is 2 power 8. So in 1 byte we can store 256 combinations. So what people did, so they mapped all the keyboard characters to one decimal number. Okay, they mapped all the keyboard characters to one decimal number. So this is how they mapped. So you just pay attention to decimal. So this is how they map. Just pay attention only to decimal. So you can store 256 decimal number in 1 byte, because you can play with zeros and ones. So what they did, they mapped the keyboard characters. Just see here, the keyboard, this is the keyboard characters. So these are keyboard characters. So what are the characters you have in keyboard? A to Z in lowercase, uppercase. You are having numbers. You are having function keys. Okay, you are having caps lock, tab, etc. Comma, comma, slash, hyphen. So every key they are mapped to one decimal. Okay, because end of the day we are going to use this data to store. Whatever you are typing, you are going to get stored, right? That is what going to get stored in files and databases. So these are the keys you are going to use while storing data. So what they did, they mapped small a to 129. They mapped space to 64. So they mapped low values. They made us low values. Lowest values, low value. Highest values, high values. To 255, they made us high value. Then mapped the space. Then mapped a to small letters. I'll share this sheet, Kiran. Then they mapped capital letters, 193 to caps. Okay, 193 to caps, and they mapped Z to 233. Then they mapped 0 to 9. Okay, 0 to 9 to 240 to 249. And there are a few more function keys I mean, hash symbol, dollar symbol, percentage, plus minus, everything is present. I didn't mention here. Okay, I didn't mention here. You can get the chart from internet. Can see the mapping. So this is how they map one character. I mean, you can store a keyboard stroke in 1 byte in this decimal position. Okay, if it is decimal, you can convert to binary. So in mainframe, data is stored in EBCDIC format. So what is EBCDIC format? EBCDIC stands for Extended Binary Coded Decimal Interchange Code. It is a double hexadecimal. So you have to divide this by hexadecimal. Can you divide this by how will you divide by hexadecimal? How will you make a value as hexadecimal? Do you remember in mathematics? What are the values we have in hexadecimal? How many values? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what?
A, B, C, D, F.
A, B, C, D, E, F. Yeah. A stands for 10. F stands for
10,
15.
11, 12.
Up to F's.
Okay. Divide 64 by 16. What are you going to get?
4.
4 and 0. Remainder 0. I'll give an easy number. Divide this 16. 164 by 16.
10 and 4.
10 and 4, right? 10 is nothing but A. And then 4 is the remainder. And probably if you are good in mathematics, you can very quickly What about this? 193 by 16.
11. Remainder is 1.
11 or 12.
12.
12. Remainder is 1. So it's 193 divided by 16. Even I'm weak in mathematics. Let me take the calculator. 193 by 16. You have
12 remainder 1.
It's going to be 12, remainder 1. That's what 12 means C, remainder 1. So this is how FCD got evolved. Okay, been created. So in 1 byte, you can store 256 combinations of data if you are going to store in binary format. And they converted to EBCDIC format, which is double hexadecimal. For first, they map low values to 0 and space to hexadecimal 40 is space. Okay, hexadecimal 81 is A, small a. Hex 82 is small b. And hexadecimal capital A is C1. C1 is A is going to be stored as C1. So in mainframe, data is stored in EBCDIC format, which is double hexadecimal. In Windows, data is going to store in ASCII format, which is zeros and ones. So in mainframe, double X, and in Windows, it's going to be ASCII format. So here, which is bigger? Capital A is bigger or small a is bigger? So data is stored in hexadecimal format. So which is bigger, capital A or small a? Is C1 bigger or 81 bigger?
C1 bigger.
C1 is bigger. Actually, in ASCII, it is reverse. They mapped capital first, small later. Okay, here it's small first, capital later. Okay, is F0 is bigger or C1 bigger?
F0.
F0. So numbers are greater than alphabets. That's what in EBCDIC. Okay, in EBCDIC, so numbers are stored how? F0, F1, F2, F3, F4, F5, F6, F7, F8, F9. So data is stored in double hexadecimal. So as I said, in 1 byte we can have 256 combinations, and these 256 combinations are 256 decimal numbers, and we can divide by hex 16 to get double hexadecimal, quotient and remainder, and they map the keys in keyboard to one of these. I'll show you. I think I have shown you then and there, but I haven't explained. Open any file. So I have to change the font also. Is it visible? The font I'm not. How to change the font? Anybody? Any idea? Customize toolbar license. We can change keyboard mapping also here. The font is very thin. We'll take any file. I'll go in view format. So this is a raw data which you can see with naked eye. If you want to see how it is stored in mainframe, put hex on or hex off. Hex off to remove, hex on. See, 0 is stored as F0, 1 is stored as F1, space is stored as 40, and D is stored as C4. Okay, W is stored as E6. If you write small w, so caps of, if you write small a, alphabets. Small a is stored as 81. So this is how data is stored. If you put hex off, it will go. So as far as mainframe is concerned, it is stored only in hexadecimal. All your operations are being done using hexadecimal. If you are giving location equal to Hyderabad, it is going to convert Hyderabad into hexadecimal and then compare, because data is end of the day is stored in hexadecimal and not in high level language. In mainframe, everything is stored in hexadecimal, and only based on hexadecimal it is going to compare. So small a is not equal to capital A. You understand? Small a is 81, capital A is C1. Both are not equal. So it is case sensitive. Everything, any software is case sensitive. As far as password is concerned, it depends. It depends on the company to company on how they design. Otherwise, all are different characters. Small a is not equal to capital A. Similarly, small a space is not equal to small a, because you are having space. Okay, and space is not equal to small a. Remember, everything is storing a different